Hi, I'm Luke Pinky, and this is my math project. I wanted to talk about this little instance of history that I discovered while I was researching. Um, so essentially, in 1600s, Newton and Leibniz, they were cooking up this pot, this cauldron that was math. It was calculus, and in my head, I imagine Leibniz and Newton just going, "At long last." And Johann Bernoulli saw this. He was from Sweden. He came from a long line of mathematicians and scientists, and he was a very competitive man. So he didn't like all the attention they were getting, and he was jealous. So essentially, he saw this problem that Galileo had thought about in the past. He wondered what the fastest arc would be from point A to point B on a line. He imagined it to be an arc of a circle, like just a semicircle kind of. Of course, that he was proved to be wrong, and he wanted to solve this. It's called the Brachistochrone problem. It comes from the Latin term for shortest time, Brachistochrone. He proposed it as a challenge to Newton and, by extension, Leibniz. The solution is defined as a cycloid, which is the roulette, which is basically the path that a point on the diameter of the circle creates. And you can see it here in performance basis, like the straight line loses out obviously, as well as this 90-degree curve. And to do this, he used Fermat's law, which is recently established as a hypothesis, which states that light will always take the shortest time, and he uses the sine of the first angle as well as the sine of the second one. And using this, we can create a hypothetical scenario of layers of liquid where light like infinitely increases and decreases in speed, where it refracts slightly more. And if you take the limit of that to infinity, you can find the Brachistochrone curve. And here I have the differential equation for it. Of course, this is a calculus that is far beyond me. I'm not going to try and do it for you in action because I don't believe I could. So essentially, he solved it with calculus by variations. And you can see here he defines the speed that it falls with the change in x times square root of x over the change in x from the original position. The rate of change in height obviously is equal to the angle of refraction times the square root of x over the constant a minus x. That's essentially big words for what I said. I've done a lot of research to try and explain this. Bernoulli expanded this with velocity squared equals a times x. Basically, he defines velocity as a times the change in x, which is let me rephrase that, the square root of a times the change of x. And then after you integrate this equation down here, you will get y equals a to the inverse sine radical x over a minus radical a times the change in x. And if you plug that into Desmos, you get to see a really nice graph of the Brachistochrone curve forming. It's kind of unknown whether Bernoulli or not had solved the problem before he proposed it, but I believe he did. So essentially, he took this problem and he wanted to test the people of the world, the mathematicians of the world, on if they could solve this problem that you really needed to understand, find calculus for. And he said, I hope to gain the gratitude of the whole scientific community by placing before the finest mathematicians of our time a problem which will test their methods and the strength of their intellect. If someone communicates to me the solution of the proposed problem, I shall publicly declare him worthy of praise. And Johann Bernoulli was known as a proud man, so this was a real declaration of war for him almost. And of course it gained the attention of Leibniz immediately because it was his student. But Isaac Newton didn't get it until he had visited France. And when he had received the problem, received the challenge, he derived a solution the same night and submitted it the next morning. which is where the hijinks continue as Johann Bernoulli delivers a truly insane line where he says, "We recognize the lion by its claw," to obviously recognizing Newton's solution by his ability. Of course, this is slightly jokes and mostly jokes, but this problem and this rivalry and this petty dispute that they had helped to advance the world of mathematics, because the only real other solutions were from L'Hopital and Leibniz, which also Jacob Bernoulli. Sorry, I should have mentioned him. He and Johann had some very, very real beef after he proposed this problem over who had solved it better or who had solved it first. And despite this, despite all the squabble it caused, it also helped to prove calculus as a legitimate study, as it was used to solve a problem of optics and physics, both in the same vein. Yeah. It proved the efficacy of calculus of variations, because Newton and Leibniz reached a solution faster than Johann, and they used a more mathematical approach rather than slightly practical or theoretical. This is my sources cited. Thank you for listening to me rant about Johann Bernoulli and Leibniz and Newton. I got really into their research. I got really into the personal aspects of it. Thank you.